Alright, hi, this is Max, working on the first problem of fall 2012, midterm 2, and it's called expressionism. Okay, so the way I like to approach these sort of what would Python print programs, or what would Python print questions, is by writing an environment diagram. It tends to be a useful way to approach these problems, so you can keep track of all these weirdly named variables that we throw up. Normally I would probably write this on a separate page because you don't have a ton of room to work here, so have some global frame. Let's start by defining the things that we read right here, right? So the countdown is equal to some function, countdown. Okay, don't read anything inside here. Another function, endeavor. Goes to a function, endeavor. Remind myself what it takes, an S and a T. Here, remind myself that this takes a K. Okay, so now I have two other variables, Atlantis and discovery, which can be the results of calling countdown on endeavor and U. Okay, so let's make a new frame for countdown. And we're passing in what endeavor as S and U for T, right? Okay, we don't need any of this anymore. Okay, cool. So now we'll read down. We've got something called buzz. It's going to point to some list out here that it's got U as its first element. Doesn't have a second element. And then we've got some function nas, which is function nas. It's defined in F1. Takes as an argument A. And then we've got another function called aldrin, which takes no arguments. Remember, parent is F1. So, okay, cool. So this looks good. Now what do we return? We're going to return nas and aldrin. And we're going to set our Atlantis equal to nas, right? So you can see here, Atlantis should be equal to nas. And discovery is going to be equal to aldrin. Alright, this is pretty ugly, but this is just scratch work, right? We're not actually going to turn this thing in. So, okay, so now we can start executing this. We've sort of done all our precursor code, and now we can start sort of looking at how we would evaluate this in here. So first we're going to call discovery. What is discovery? I need to evaluate my operator. My operator is actually the function aldrin. And aldrin is going to print. Aldrin is we're going to look at what aldrin is. Aldrin is up here. It's going to return buzz. We're going to make a new, normally we would make a new frame for this, but it doesn't actually have anything, so we can sort of keep track of it in our head. Buzz is equal to whatever buzz is equal to up here, which in this case is this U. So we're just going to get a list, or this list that contains a U. We can get a list that looks like that. Okay. Now we're going to call Atlantis on 1. What is Atlantis? You can see Atlantis is equal down to nas. NAS, we're going to probably want to make a new frame for this. I don't have a lot of room, so I'll probably just make it down here for the meantime. Then I'll erase it afterwards, just so that we can keep track of stuff. Hopefully this doesn't mess anything up. We'll find out. Okay, so we got F2. We're going to call this Atlantis. And what do we do inside of Atlantis? Actually, we'll call this NAS, right? Because we're actually using NAS. And its parent is global. I'm sorry, its parent is F1. So we're going to use parent is F1 so we know where to go afterwards. So we're looking at non-local T. So we're actually going to edit this T up here. I'm going to say T is equal to buzz 0, which is U, right, plus S. Okay, so we want to modify this list, or this string, to be U plus S. Okay, and now we say buzz.append T. So we figure out where buzz is. We're able to look at buzz from outside of our frame, or from looking at our parent, because we're called from within our parent. So buzz is equal to this, and so we want to append something to it. In this case, we want to append T. The value of T is US. Gonna append t to buzz. Now we want to return SA. We don't have an S in this frame. Go look at our S up here. S is actually equal to endeavor. So we can call endeavor. Oh goodness. Endeavor, we're passing in A. What's our A here? It's what we originally called NAS with, which was 1. So should have put that in the first time we saw it. 1. So now we're returning S of A, which is endeavor of A. And endeavor is going to return, so we got like a frame 3 here, endeavor. Endeavor takes some argument k. K in this case is equal to 1. And do 1 times the length of discovery. Discovery, what is discovery? Okay, we don't have a discovery here. We should look at our parent, which is global. Oh no, whatever. Parent is global. So we'll go to our parent, global. Discovery is equal to the function Aldrin. Aldrin is here, it's going to return buzz. So we're going to return we can replace this here with the length, or with buzz. Our current buzz is 2, right? Our current buzz is, current buzz length is 2. So we can say k times 2. So our return value is going to be equal to 1 times 2, which is 2. And that's what we're asked. And that's all we need to return for this. I think we should just return a 2 here. And now notice we've actually modified t and modified buzz. So now we're done with this. I'm going to erase this to save room. Okay, so now we're calling Atlantis on the argument length discovery. So first let's figure out what our operator is. Operator is Atlantis. Atlantis is actually the function NAS, which we've just called before. So now let's figure out what length discovery is. So we evaluated our operator, we now want to evaluate our operands. We have to call discovery. Discovery, we go up here, discovery is equal to Aldrin. Aldrin just returns what buzz is. Buzz is US, which is going to have a length of 2. So we're going to call Atlantis with 2. Right? Which is actually calling NAS with 2. So let's make a new frame here. NAS F2. Remember the parent of NAS is F1. We pass in A is 2. We should pretty much do exactly what we did last time. Gonna go to our T. We're gonna modify our non-local T here, right here, by taking buzz 0 plus S. Buzz 0 is still U, plus S is still US, so T is not going to be any different. Buzz, however, we're going to afterwards append T, so we have this buzz right here. What we should do is take buzz, add another US, which is T's current value. Let's not forget where Atlantis was pointing. Atlantis was pointing to NAS. Okay. And now we want to return SA. S is what we originally passed into countdown, which points to endeavor. Make a new frame for endeavor. I always make this NAS frame too big. F3 is endeavor. Endeavor is going to return what we passed in, which was k is 2, times the length of our list, which is 3. So we're going to say it's going to return length of times length of discovery, which is just the length of buzz, which is going to be 3. So our return value here is going to be 6. Our return value here is going to be 6. We can do a sanity check. We haven't printed anything. This looks like it should be 6. Okay. Erase this again. Now we're calling discovery. What is discovery? We can look up here. Discovery is equal to the function Aldrin. Aldrin is going to return buzz, which we look up here. So we look in our parent frame, right, which is this countdown frame. Buzz is equal to U, US, US. So we can just return this. Alright, so that's the first problem in the midterm. Leave any comments on YouTube or on Piazza if you have any questions, and we'll try and get them answered. Okay, thanks for watching.